Hello everyone, welcome back to Exampreptool. So in this lecture, I'll be talking about another important topic from machine learning, which is KNN and K-Means. Though they are two different algorithms, but within this lecture, I'll talk about that how they're different algorithms, but the basic principle, the way they work is similar. So principle that means what you actually need to do. Okay, the algorithm is different, but as I mentioned, the underlying idea remains same. So I'll talk about that. And I hope you liked the previous lecture, which was on linear regression, where we talked about that how linear regression come into the picture, how do we find out the best fitting line, what is the loss function and all that, and like vectorization part also we understood that if we want to find out that what should be the weights directly from normal equation, how do we find it out? Okay, using all the gradient was not the gradient, but how do we actually resolve by taking the derivative and putting it to zero. Okay, so I hope you loved that lecture. So as I mentioned, now we'll continue with the next possible important concept, which is KNN K-Means. So let's get started. Cool. So I hope my screen is visible. So first of all, I'll tell that what exactly are the two algorithms which we are going to talk about. So it's like simple KNN and K-Means we'll be talking about. Okay. Now, if we understand what exactly both of these are actually talking about, and then I'll give you the contrast, like what exactly is the difference between these two, and then we'll go one by one for each of these. Okay. So if I talk about KNN, or basically like the underlying idea is in general in real world the similar looking items which share the same behavior or they have a same pattern would be lying close to each other in a proximity. So that means something like this. If I have a picture of like cats and dogs, and if I just want to classify a picture as cat or a dog, I know that most of the cat pictures would be having similar kind of attributes. That means the ears, the way their ears would be there, the small face they'll be having, the eyes, the whiskers, and all that, and the nose as well. Like it's a small nose they are having. Okay, then we have dogs which have like a little extended mouth kind of a thing, a big nose they are having, and then they also have like some round ears. Well, like there are a variation for the dogs as well. There may be some dogs which might look like like some cats, the small dogs I'm talking about that. But leave those exceptions aside, so you will know that there would be some similar kind of attributes in all the dogs picture, and similar kind of attributes or properties for cat pictures. So they should be in our like high dimensional space. So it's like this. If I just want to talk about, forget about the pictures also. So if I'm just considering, let's suppose the weight, and let's suppose the height. Okay, and let me just based on weights and height only, if I just consider, so I know like in general the cats would be smaller and dogs would be much bigger. In general I'm talking about. Okay, so I know that in if I just consider this two-dimensional space, so the cats would be lying somewhat over here where weights and height both are less, and dogs might be most of the time would be lying over here if I'm considering this to be weight and this is height. So I know, as I mentioned, so dogs would be much higher in weight and height as well. So that is the idea, that the sharing property, or basically what should I say, the similar looking data points, or what should I say, the pictures would be having some shared characteristics. They would be lying close to each other in a proximity. Okay, so that means they are closed over here with each other, something like this. Okay, and that exactly is the idea for the KNN and the K-means as well. Now what do I mean by that? Let me just go to the next slide and just talk about that. When I'm saying, so it's about both algorithm uses a distance matrix. Now, what is this distance metric I'm talking about? See, so we can have a number of distances. Let's not get into that. So, like, one would be the Euclidean distance. Like, the detail we will not get into that, but just giving some examples. So, one can be something like, as I mentioned, the Euclidean distance we can have, and then we can have L1 distance, which is Manhattan distance. We can have cosine distance as well, based on the what should I say, the angle between the 2 points we are having. If I consider them to be simple vectors, and similarly, on other lines, we have some other kind of a distance as well. Like generalized one is Minkowski distance. And if I talk about considering the probabilistic way of looking at the distances, then we can have something known as Mahalanobis distance as well. Okay, so we have a different variation. So both of these algorithm would need a particular distance metric, and then they would like to say that where distance are, where the distance between two data points are less, they are going to be much look-alike, or they are going to be belonging to the same category, kind of a thing. So that means if I'm saying, just giving you the example that, okay, we are having something over here, some set of data points over here, some set of data points over here, okay, and then I'm bringing a new data point over here. Let's suppose something like this. This is the new data point. So I would like to see that what is the distance of this one from this or from this. So I know, like, these are much closer to this data point. So this would be having a shared behavior from this kind of a category, rather than this sharing behavior from this category, because this is much closer as compared to this. So this is the core idea. Okay, now you have understood that what I'm talking about is, if there are similar looking, shared characteristics, similar behavior, we are going to talk about similar pattern we are talking about. In that case, always look-alike or similar data points would be having smaller distance or more similarity between them, rather than someone else which is a little farther, which is less similar or having more distance. Now, if this idea is clear, this makes the foundation for both the algorithms. Now, I'll just give you the contrast, because this was the underlying idea. Based on similarity or distance, similarity would be just opposite of your distance. So if similarity is high, distance would be less. If distance is high, similarity would be less. I hope that idea itself is clear. So I can just write it out over here. That similarity idea would be like inverse of distance. If I'm having higher distance, similarity would be lesser. If I'm having lower distance, similarity would be higher in that case. Okay, so that is the idea. Now, if I just compare these two, because we have to go one by one for each of those, KNN and K-means, I'll talk about now what exactly is the difference and what is the confusing part as well for them. So if I just bring it up, so let's just talk about the very basic, like full form. K nearest neighbor. And this is like it's already mentioned. So K means this is a supervised algorithm. And this is unsupervised. So if I talk about what exactly in supervised, so it can be used for both regression and classification. And I will talk about the classification problem. And the K-means is basically for the clustering. Okay. So what do I mean by this is, that means in KNNs, I need some labels. So for an example, as I talk about the example earlier as well, that, it's like this. So we have a bunch of cat pictures or cat properties. We have a bunch of dog properties. Now, if I get a new data point for which I do not know what is the label, that means getting a picture, I don't know whether it's a cat or a dog. I want to say, is it a cat or a dog? I would like to check the similarity around it. That, okay, given this particular query point, like whatever you are testing on, what are the closest members I'm having? What are the closest pictures I'm having or properties I'm having? and to what category, to what class, or to what animal does those pictures or property belong. Is it that in my nearby area, is it the cat pictures or cat properties which are dominant than dog? In that case, the new testing point would be called as cat. If it's the dog pictures or dog properties which are in the nearby area, in that case it would be said to be called as a dog picture or dog properties. I hope KNN idea is clear. So what does K tells over here? K tells me, K tells that number of neighbors I'll be talking about, number of neighbors to look for. So that means if I have a query point, I would be looking for, searching for, if this is 3 nearest neighbor, I would look for 3 nearest possible pictures or 3 nearest possible data point, and would like to see what is the dominant class within that. Whichever is the dominant class, my class for this particular data point would become the same. So if it's the cat pictures or cat properties around, I would say this query point is also cat. If it's a dog, in that case, I would call it as dog. Number of neighbors to look for to decide final target variable. And there can be mixed pictures as well. So for an example, I'm just giving you an example over here, just for understanding purpose. If I'm having, let's suppose this is my query point, and I have, let me just bring it up as well. So I had a cat picture over here, cat picture over here, but along with that, I had a dog picture over here as well. Like, I'm just talking about within this 2-dimensional space, we had something like this. This is the query data point I'm having. So you can see there are 2 cat pictures or 2 cat like data points belong like which are present, and this one is a dog one. So if I just look at 3 nearest neighbor, I'm getting these 3. Now what should be the label for this query data point, this data point? Whichever is dominant. Okay, so out of 3 there are 2 which belongs to cat, so it would be called as cat. Simple, very simple. Okay, so this is the idea around k nearest neighbor. And on a similar line, if it's a regression problem, whatever are the nearest values or data points I'm having, I would like to take an average of that. Basically, some aggregation is done on that to give the final value. For an example, if I wanted to predict the price of houses, I would like to see for the 3 nearest neighbor, what is the price of this house, this house, this house, and would like to average that to return what is going to be my overall price of this house. Okay, I hope that idea is clear now. Now, if I just talk about, so now if we talk about, so I hope this KNN idea is clear with respect to the regression as well. So I'll just look at the nearest neighbors. Whatever was their target variable will take the and any aggregation on that. It can be a mean or a median if it's like important for us. So based on that, we would like to return what should be the target variable for this query data point. Now this is the idea for KNN. Now if I talk about what is the idea for the K-means, what actually goes into that is, now let me just talk about that as well. So as I mentioned, it is also a similar thing. So in supervised learning, we do not really have labels, and K-means is actually a unsupervised learning algorithm. So we won't be having labels. So that means we just have data points present, and clustering is a problem in which we would like to see what are the similar looking, like how many categories are present, for which we do not know what are those categories, but what are the what should I say, is there a shared behavior within my data points? Like, is there any area, region where, okay, some of the data points belong to this region, some of these belongs to this region, something like this. A simple idea can be, let's suppose I just had the weight and height, like the problem I talked about initially for the cat and dogs. So let's suppose I do not know whether it's a cat or a dog, but I had the entire data in which weight and height were only present, something like this. So I'm saying, so I had just weights and height. I know that, okay, this belongs to a cat or a dog, but I'm not considering it within this data. Let's suppose if something like this is given, what would be K-means telling me? I'm just talking about this. So I'll be having the values over here, values over here. And if I would like to plot it up based on that, what I'll be getting is some of the data points would be lying over here closer to each other. Some data points would be over here. Some outlierish thing can be present, something like this. But most of the data points would be lying over here or over here. Now I know by default, by understanding that, okay, this would be actually those data points which belong to a cat, and these would be one which belong to a dog. So like, I hope you are getting that what is happening over there as well. I do not know about the labels, but based on the properties, I know the similar looking data points or shared behavior, similar pattern would be binding all the similar looking data points together. So this is the idea. Like, I hope you could see. Now, how does it work? In KNN, we talked about the nearest neighbor we were talking about. In K-means, what happens is we actually try to first of all talk about how many clusters are present. That means how many categories or regions can be formed within while plotting this these particular set of data points. So for an example, if I'm saying like right now we had the idea that we have two categories over here or two clusters which would be there, but if I don't know, we need to just identify what can be the number of cluster present. Okay, something like this. So based on that, so K over here would be number of categories or cluster we would like to find. We want to find. Okay, now how does it take place? So we'll get into the details of both the algorithms, but right now just understanding. So how do we find out is we will have to initialize the centroid as in just consider something like cluster center. So I know like a simple thing can be, so if I'm talking about a Bangalore or a Delhi, there would always be a Bangalore center point, there would be a Delhi center point, there would be a Mumbai center point, okay, which will tell that okay, nearby area actually belongs to Mumbai. Okay, for Delhi similarly, for Bangalore similarly. So we have to first of all tell how many categories or clusters we would like to find out, and then we have to initialize initially that okay, what can be the what should I say, what can be the initial cluster center for these. Okay, if I know that, in that case now I would like to check out. Okay, for an example, let's suppose if I'm saying this is one of the cluster center I'm talking about and this is the other one, I would like to check out how many data points are closer to this, how many are closer to this. The one which will be more closer to this than this would be called as that okay, the cluster containing data points would be all those which were closer to this. That means all those data points which were closer to this would become part of the cluster for which this was the center. All those data points for which the distance would be lesser for this one rather than this, then that means all those data points would be called as a part of cluster for which center was this. And this way we are actually finding out what should be the data points belonging to which cluster. And there is a proper iterative process in which we keep on finding best possible cluster centers every time, and that's how it proceeds and we find out. So I hope the idea between both of these two are clear. They use the same underlying principle, which is the distance or similarity, to say the similar looking would be closer to each other, the different ones would be a little farther, and we need to just consider the similar one. So if it's a classification, it's a supervised learning process, in that case I have a label to talk about. In that case, if it's a classification problem, I would just look at the nearest 3, 4, 5, and then whichever is the majority class over there, I would like to say that this data point would belong to this. Okay, and similarly if it's a regression, so whatever are the k nearest neighbor, 5, 3, 2, whatever you want to initially decide, I will take an average or an aggregation would be done for the target variable to decide what should be the target variable for this one. If I talk about the k-means, the idea is again same, but I have to, there are two things, two part to the k-means name itself. K tells me how many cluster we are talking about, that what would be the overall different bunch of data points I can say, okay, overall category or clusters. That is being said by K. What is means telling me that how do I actually find out the cluster center? That is being find out using with the help of mean function. So that means if I have all the data points belonging to this cluster, a particular cluster, let's suppose A, then what would be the cluster center? That would be calculated using the mean of that, and that would be called as cluster center. That would decide for any new point what should be kind of that, to what cluster it should belong, something like this. I hope this particular idea is clear over here now. Now we'll get into that what actually goes into each one of these. So we'll talk about the KNN first. The better example would be, let me just take 3. So let's say k is equal to 3. Okay. So the moment I say k is equal to 3, that means I'll be talking about 3 nearest neighbors. 3 nearest neighbors. So what happens is, I'll be having some data points for me. Okay. So you have already listened to the story while I was introducing this. So you already have a data points. And then if you want to find out if I bring in a new data point, what should be the class or target variable for that? We just look for 3 nearest neighbor, and whatever is their target variable, we just decide based on that. So if you just look at this is actually lazy learner. I'll talk about what exactly is a lazy learner. This is a non-parametric approach because there is no assumption with respect to the distribution of data points we are having. Okay, no, a non-parametric algorithm. So non-parametric just because of the reason that we are not actually looking for any parameter that will decide the distribution. Nothing like that. Okay. Like in the other, we have some parameters to actually find out always. Okay. Over here, we do not really have that. And with respect to the lazy learner, what does it mean? So if I say what is the training process, what would be the training process? If I tell you that these are the, let's suppose 100 data points I have given and 3 nearest neighbor we are talking about, what would be happening in training? So unless I have a query point to tell its class, I do not really need those 100 data points to do anything. Because the moment somebody tells me, oh, decide what should be the class for this, in that case, I'll be calculating the distances and all. But for the training purpose itself, can I store something or like, do I have something over there? The answer is literally nothing is there with respect to the training part. Okay. Because for training, what generally means is I'm actually finding out some parameters and would like to use it for the testing purpose. But really, we are not really finding any kind of parameters over here. So for lazy learner, why do we call it? Because there is no training actually. But there can be some training error or test error, which we'll talk about. So there is no training. So in testing or inferencing time, what happens in that case? So when we are testing out, in that case, I'll get a query data point or maybe a bunch of query data point. I would like to calculate the distance from all the existing data point. Now, the next thing would be what are the closest one, find out that, and then look at their simply target variable. So if I want to write the algorithm for that, what should it be? A simple idea would be to write. So let me just add to that. Why lazy learner? Because there is no training. Okay. Now the algorithm, if I just talk about what should be the algorithm like. See, there is no training. So in the name of training, the only thing which we can do is we can just store the data points which we are having as a part of training. So for training, in training, what do we do? Store all the training data. We just need to store the training data because ultimately while testing out, I would use these training data points to find out among these training points, what were the closer to test data point. Training data points. Okay. In test, what would be happening? For this 3 nearest neighbor I'm talking about, and let's suppose there is only one query data point I'm talking about. So assumption, let me just write down some assumption so that it's clear and we do not deviate from that. Assumption, only one testing point, and whatever we'll be doing for one testing point, the same goes for every test point. Okay, so the steps are something like this. So let me just write steps over here. So the first step would be calculate distance slash similarity of this test point from all the training data points. Because see, while plotting I can see and visualize which data points are closer, but if I have just the data and I'm not plotting it, I do not know what are the closest data points. So I have to find out the distance and look at what is the minimum distance, or I have to find out the similarity and then look at the which one is the high, which are the data points which are having maximum similarity from all the training data points. So find out those training data points. Find out 3, because we have a number already decided for that, and we are talking about 3 nearest neighbor. I'll talk about like why 3 or why not 5, why not 7. 3 training data points which have least distance or highest similarity distance to query, means I'm talking about the test data point. Third step would be the last one, which would be just based on regression or classification. Use above, or rather I should say use data points found in previous step. Use 3 data points in previous step to decide what are we going to decide? Target variable. And what in that exactly? So that means if it was a regression, take mean of their target variable. If it's a classification, look at dominating class. Look at dominating class. Which is the dominating class? Would be the class for this particular variable. Now I'll take some example over here. Okay, I'll very simple example. We will not be exactly calculating everything like this, but just to show what would be happening. How does it happen? We'll talk about that. Okay, So let's just frame an example, and then we are nearly done with nearest neighbor. Example. Okay. So let's suppose it's a binary classification problem I'm talking about. So there will be two classes. So let me just mark like this. Okay. So see, over here we do not really have a, you can see like it's not linearly separable. I hope you can see that. Linearly separable means I cannot simply draw a line and separate both the classes. Instead of crosses, let me just use the circles for these. So this is not linearly separable. So this is also one of the beauty with KNN, that it doesn't really depend on, like, it doesn't really have any assumption about the data. It just works. Okay, so it need not be linearly separable or non-linear separable. It would work anyhow. So let's suppose if I get and it's the three nearest neighbor only I'm talking about, and my test data point is something like this. Let's suppose if the test data point is this one, what would be called as what should I say, uh, the class for this one? So let me say this is test data point T, this exactly T, lying over here in between these two, and vertically sorry, yeah, vertically on the same level as these two, and horizontally in between, exactly so over here. Okay, so what should be the target class of this one? I would look for three nearest neighbor. So one neighbor is this one on the left, one is on the right. You can see the, so two are found. Now what would be the third nearest neighbor? Should it be this one? 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 Which one? So it's a little like not an easy problem, or I can just make a little easier right now, and then we can later like argue about what should be happening. Let's suppose, yeah, something like this. So let's suppose right now the data looks like this right now. So you can see the distance of this one overall. What would be the closest nearest neighbors? It is going to be this, this, and this. So these are the three nearest neighbors. Now, like if I would like to go by the algorithm, I would like to find out the distance of this from this, and this all. We will sort them up somehow. Okay, so that I get to know what are the least distance point, okay, from this test data point. Now once I did that, I know like it is going to be 1 2 3. Now what are the ones which will be deciding the class for this one? So out of three, two belongs to the circle, one belongs to the cross. So what would be the class for this? It would be a circle class, which is like a light green color class for this one. I hope the idea is clear. Now, if I just add this thing up as well, what? Let's suppose if I add this point also over here, what would be happening in this case? Like if I just add it up, so I know with respect to the distances, overall this and this would be having same distance to this 1 2 3 4. You can see, so these were the two closest one. The moment I get to the next closest, both of these two would be having the same distance. Now over here, this is a major problem as well. We always have a tiebreaker. What would happen? So over here, what would happen is, I would like to check out, there would be a tiebreaker that, okay, which one should I go with the lesser like X value, or more Y value, something like this. Or it can be something like, we will consider four, all four. This was three nearest neighbor, but we'll consider all four. Okay. And then based on that, we will be deciding something. It happens. But the idea remains same. The moment it said 3, I would need basically 3. If there is any other as well, there would be a tiebreaker which will help us decide what are the top 3 I'm going to consider. Or in case I'm bringing the fourth one also to be part of this, just because third and fourth data point had the same distance, there would be a way to actually decide within that. It would be provided in the question. No need to worry about that. Okay, so this is the idea around the nearest neighbor. How does it work? Now, 2 3 important things over here. First thing over here is what should be the value of k, like how many nearest neighbor I should talk about, or how many nearest neighbor I should look at while deciding that okay, I'll be solving this problem. So for this thing, what generally happens is we always want odd value of k. Why? So that it's easier to decide. Because if I say 4 nearest neighbor, 6 nearest neighbor, there can be the ties which can take place, because for even numbers, 2 can belong to one class, 2 can belong to the other class. I need to have tiebreaker every time in case there is this possibility. If I'm having 6 nearest neighbor talking about, then 3 can be the case. I don't want that. If in while keeping this thing like 3 nearest neighbor, if I'm getting this, that's one kind of an exception I'm getting, but not always. So if I have just 3 nearest neighbor I'm going to talk about, I know one would be the majority class, other would be the minority, and majority would be called as the class for my test variable. So that is the idea behind keeping odd value for my nearest neighbor, not the even value. Okay, this idea is clear. Now, the last thing which I can discuss with respect to this thing is, I guess, yeah, like within that. So, like how would I find out, how test error and training error are used? So, what happens is test and train error. And test error. So what would be happening for test and train error? What do you think is the training error over here? If I would like to find out what is going to be overall training error, what would be happening? So the training error would mean how would I classify each of the data point as? So there is no training taking place. You already know that. But if somebody wants to check out what should be the training error, what would be happening is I'll treat each training data point as a test point at that point of time, and would like to see what are the nearest neighbor. Based on that, I would determine what is going to be the class for this one. Based on that itself, I'll be able to find out how many times for each of the training point I was wrong, how many times I was correct. And then correspondingly, I'll have an error as well. Basically, we can talk about the accuracy. For the testing also, it's same, but in testing, I would have a outside point, not outside, like outside doesn't mean that something beyond all these data points, but something I have not seen in the training. So that means for testing, the query data point would be using all the training data points to decide that. But for training error, if you want to find out, every time whatever training point you pick up, that point for that moment would become a query point, and all of those would behave similar to like a normal training data points. So that is the idea between training error and the test error for the k nearest neighbor. Now, if I talk about one nearest neighbor, what would happen? 3 nearest neighbor, what would happen? 5 nearest neighbor, what would happen? Let's suppose 7 nearest neighbor, what would happen? So if I keep increasing the value of k, what would keep on happening? I need to just talk about that. So it's like this. If I talk about, if I'm using one nearest neighbor, that means I'll just look at what is the closest data point, what is the class of that. I'll just say that this is the this is going to be the class for my test data point or query data point. In 3, I will look for 3 nearest neighbor, 5, 7. So what would happen is, for the example like this, I might get a very zigzaggy or patchy kind of a decision boundary. But for as I keep on increasing k, my decision boundaries would become smoother and smoother. What do I mean by that? I'll just give you a simple example for that. So let's suppose this one is something. So I hope you can see what I'm going to talk about. So if I consider, so let me just bring up the decision boundary using each of the 1, 3, and 5 only. Okay. So if I just look at the one nearest neighbor, so I know for one nearest neighbor, if I'm just going to talk about one nearest neighbor, if I get any data point, I would just use the first closest one, and that would decide my what should be the class. So you can see that what should I say, the breaking, or what should I say, like if I have two data points belonging to different class, in that case what should be the deciding factor, that exactly this line would be the middle ground. If it is on the left of this, it would be called as cross. If it is on right hand side, it would be called as a circle, something like this. And we'll be having something like this. This is based on one nearest neighbor. Like I'm closing it up, but it would not be closed, because if I have a data point over here, I would like to check what is the nearest neighbor. Is it this or this? So based on that, I can decide. So I hope you can see for this one, I would just look at like any data point which would be crossing this boundary would be called as cross. Within this boundary would be called as circle. Similarly, over here, any data point within this red boundary would be called as cross. Outside this would be called as circle, because circle would be more closer than the crosses over here. So this is what is happening because of one nearest neighbor. If I make it 3, in that case, it would become a little smoother. It would not be patchy. Patchy as in that small area within area itself you are able to find which are belonging to different class. Now, if I make it 3, what would be happening is, so you can see overall over here also it would be simply what should I say, like among these 3, if I just figure out, it would be circle always. Among these 3 it would be a circle. Among these 3 it would be a sorry, cross and cross. Over here it would be a circle. So it would reduce, this patch size would reduce, because if I'm increasing the nearest neighbor, I would go a little far to look at what are the closest one. So in that case, what would be happening is, and this was also like this only, something like this. Okay. I don't want to close it up, so that's why I'm not creating any boundary over here. And this would also go like something like this only. If I consider 3 nearest neighbor, it would be that I know like this is going to be limited to something like this. Mhm. Very small boundary would be there for it to be called as what, something like this. It would reduce what should I, for the cross, yeah, this is fine. Over here also it is this. Over here it's not, so it would be somewhat over here only along this line. If I just have these, okay, something on this, and then both the sides, so it would be more like this. We would not be able to go above much, because if I go above, I am getting circles over here, but within this I can see there are 2 crosses which will dominate any circular data point, and then rest of these are like Fine. Rest of these would be just circles only. If I talk about this one, I had only one circle. So even if I just look at any data point within this area, there is a possibility that only one would be a circle, rest of these would be a simple crosses. So this would be entirely a cross area. No circular area would be present over here. Okay, now if I make it to 5, in that case what I would say is there would be no cross possibility over here, because I know there are only 2 data points and majority has to be 3 for it to be called as cross. So in that case the entire area would become this time circle, and over here entire area would become a cross. So I hope you can see the patch would reduce and overall area for each of the majority class actually increases as I keep on increasing the k value. Now if I make k is equal to the number of data points, what would be happening in that case? In that case, every data point, every query data point would be called as that belonging to that class, which was the majority class in all of my training data points. So for an example, if I had 10 data points only, and I out of that I know 7 were circles, 3 were crosses, and I am saying that I'm looking at 10 nearest neighbors only. So in that case, what would be happening? All the training data points would be the nearest neighbors, and then whichever is the majority class, 7 circles. So circle would be called as the majority class, and the new query data point would be called to be belonging to this circle data circle class in that case. I hope this particular idea over here for nearest neighbor is clear, and this is all about the k nearest neighbor in short. Now if you want to learn more about like the bias variance thing, the different distance metric, I hope this would be a clear very interesting thing which you can see after enrolling in the paid course. But yeah, just to understand at a ground level, and you'll be able to solve the questions with the help of these only. If it's a simple, you want to just classify the data point, you'll be able to find out what should be the class using this only. Okay, so that was all about your k nearest neighbor. Now let's get into the idea for k-means. So the idea of k-means is that we are going to have k clusters. To have k clusters. Okay. So like, because we have already talked about this, so we are already saying k would be telling me how many clusters would be there, and cluster center would be told by what is the word being used over here. Would help determine cluster center. Cluster center based on data points belonging to cluster. So there is a possibility that there is a like a sister algorithm as well, not k-means, which is k-medoids. So what happens is then also we use actually k clusters are being found, but to find out the cluster center we use median over there. What? Median over there. Rather than finding out the mean of all the data points belonging to that cluster, we use median of all the data points to say what is going to be the cluster center. So I hope the idea is clear. Now, what is the algorithm? I'll just talk about that. And like the moment I write the first thing itself, you'll get to know that this is one of the thing over here, like biggest advantage or disadvantage you can get into k-means, which is we initialize the cluster center always. The cluster center, and that can be one of the data point you can consider, or you can just consider the it just depends. You can start with the random random initializer as well. So I'll just bring up one good example over here as well, which we have seen our RIC batch classes as well, where we had solved this problem as well. We'll see that example again over here. So we initialize the cluster centers before training, or we guess it. Okay. Now within algorithm, what actually goes is, it's the training algorithm, rather I would say. First step would be find out membership of each data point to cluster centers, to initialized cluster centers. That means what? That means I have told that I am talking about, let's suppose 3 cluster, 2 cluster, let's suppose 2 cluster I'm talking about. So I will look at which data point would belong to which cluster. So first initialized cluster center was telling me that it is the center for cluster 1. Second initialized cluster center was talking about that this is the center for second cluster. Now I would like to calculate the distance for all the training data points to these cluster centers. Whichever distance would be lesser, I would say this data points belong to this particular cluster. In that case, that means it is a member of this this cluster. In that case, cluster center using any pre-decided, because there can be a number of different distance metrics which we can use, but we stick to just one normally. So the general idea is we stick to just one, but you can just use other distance metric as well. Pre-decided distance metric. So for an example, if I'm having 10 data points, and I'm having 2 cluster center, C1, C2 cluster center, I would like to calculate the distance of all the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For all, I'll calculate the distance from each of these. Just to represent it, that means I'll calculate the distance of 9th point to C1, 9th point to C2, 1 to C1, 1 to C2, 2 to C1, 2 to C2. I'll calculate all these distances. Now for each of these, whichever distance would be lesser, I would pick that cluster as the deciding center. I would use that as the cluster for this particular data point. For an example, 9 would belong to either C1 or C2. It depends upon the distance from cluster center. 1 would belong to either cluster 1 or cluster 2, depending upon which distance is lesser, to C1 or to C2. Okay. Now based on this, we actually do that. Now what happens? So now what is going to happen is something like this. So I know the membership now, that something like this would be there. That C1 would contain, just for an example sake, I'm talking about 1, 3, 5, and let's suppose 6. And C2 contains 2, 4, 7, 8, 9, and 10. We found out. Now the step 2 is something which would just keep on going. What we actually did was, not the step 2, but yeah, we'll just, what is 2? Find out new cluster center based on membership. That means now C1 center would be nothing but mean of what is the what should I say, DP1 plus dp2, sorry, not 2, 3 plus dp5 plus dp6 divide by how many are there? 6. Let me just remove this sigma. So that means dp1 plus dp3 plus dp5 plus dp6 by 6. That means over here I'm just writing dp, but it matters that what is the dimension overall, in which dimension space I'm talking about. So if it's a two-dimensional, I'll simply do x1 plus x3 plus x5 plus x6 by 6 would give me the x coordinate of the new cluster center. And for the y coordinate, I would again do y1 plus y3 plus y5 plus y6 by it has to be 4. There are 4 members now, so it has to be 4. Sorry, my bad. And similarly c2 center would be calculated like dp2 plus dp4 plus dp7 plus dp8 plus dp9 plus dp10 by overall 6. Okay, so that means for x coordinate, you'll add on all the x coordinate, divide by 6. For y coordinate, divide all the y coordinates, divide by 6. We got the new cluster center. Now, what would keep on happening? Third step is repeat 1 and 2 steps until cluster center do not change. So if it is changing, keep doing it. If you have reached a point where the cluster centers are not changing, then we stop. Same cluster center do not change. Center do not change. And that is the algorithm for our K-means. So see, what would happen is every time if I'm getting some membership issue, that means from this I'm getting some assigned to this, from this cluster I'm getting some assigned to this. If this is happening, the cluster center would change. But if at any point of time the membership of all the existing cluster data points would not change, in that case cluster center will also not change. So if that converges, that means the cluster center is not changing, the algorithm ends, and we have come up to the final idea that what should be the cluster center for each of the mentioned cluster, like number of clusters we were talking about. So if it was 2 means, 3 means, 5 means, so we'll have all the cluster centers for that many 2, 3, 5 category, or that many clusters. We have it. Okay, so we'll take an example of this, and which will actually solve this problem as well, which I was talking about, that initialization can be a problem. If initialization is bad, in that case we might have an issue. We might suffer from some problem over here. Now let me just give you that idea. So as it is a unsupervised learning, so there is no label, there are just data points. I hope, I don't know, but I hope you have seen this. And let's suppose the cluster center are like this. So right now, if I just look at this, I hope you can see these are much closer to each other than these. So that means this should be the first cluster, this should be the second cluster. And I'm talking about right now, let's suppose I'm considering 2 means problem. Okay. So now, depending upon how I would initialize it, if I initialize it like this, C1, C2, C1 cluster, C2 cluster. So this is just initialization. What would happen? So the first step itself would be, you can see, it goes like this. I'm just making them closer to each other so that it doesn't make a problem. So you can see all these 4 data points would be closer to this, all these 4 data points would be closer to this, and there would be no change further. So that means this and this would be closer to this. This will not be closer to this. This will not be closer. This will not be closer. This will not be closer. So that means all these four would belong to the first cluster. All the rest would belong to the second cluster. So that means I can draw it like this. This would be the first cluster. This would be the second cluster. I found it, the membership. Now, what would be the new centroid? What would be the new center for cluster center for this? This would become, because if I take the average of all, I'll get this one as the cluster center. I would get this as the cluster center. Now, if I just recalculate, what would change? Nothing would change, because I know these are closer to this, these are closer to this, these are closer to this, these are closer to this. So the algorithm would stop over here, stops. Okay, and that means these are the two cluster I'm having, but I know this is not a quality cluster, because ideally the cluster should have been something like this first and this one as second. Okay, now this is the problem with initialization. So if I initialize like this was the problem. Now what can be the other thing? So if I initialize like this, another example I'm bringing. Using the same training data points, I'm just showing that how does this vary. So if I'm showing that one is, let's suppose this one. This is first cluster center, and this is okay, yeah, let me just say this is second cluster center, just for the example. This is C2, this is C1. Okay, now what would happen is, let me just bring up this possibility as well. Let me remove this. Let me say exactly middle of these. Exactly middle over here. This is C2 cluster center. Let's suppose we are just initializing. We don't know the membership, because when we start, we don't know like which data points belong to which particular cluster in that case. So what would happen in this case is, I would like to find out the distance of all. So I know, like ideally, let me just push it as well a bit farther so that it doesn't really bother much. So let me say that C1 was actually present over here. Okay, so you can see that every data point would be belonging to C2 only, but C1 would have nothing over here. I hope you can see that. Because see, C2 is closer to this, then C1, C2 is closer to this, C2 is closer to this, and all these, definitely C1 is on left side and all these are right. So C2 is closer. So that means you can see all the data points would belong in first iteration to C2, but not C1. C1 would be empty right now. So that means C1 would not change, C1 would remain same, but for C2 what would happen is all this would become just one cluster. So that means if I had become one cluster, what would change? In that case, the centroid would change, the cluster center would change. So what would happen? I would just draw it once again. Same thing. Now, if I talk about C2 center, after the update, what would be my C2 center? It would be the center of all, which I hope you would agree would be this C2. And C1 is still over here. Okay, it is still over here. Now, what would happen next? I hope you can see these are definitely closer to this. For this one, I can see this would be much closer to these two, and this would be even if I consider, let's suppose C2 was closer. For instance, let's suppose C2 was closer to this. So I hope you can see now what is going to happen is, now this one would become C2 cluster and this one would become C1 cluster, because these two are closer to C1, and I'm just assuming right now that these two are closer to C2. So what would happen again? Now this is going to be the cluster, and what would be the center of that? Because we have more data point over here, it would shift a little more. So I would say, let's suppose this one is C2 now, and because this one was the cluster, so that means what would be the center of this? This would be C1. Now what would be the next thing happening? I would again calculate the membership. So this time these two are closer to this one than this. So what would happen? You know now, and we are going to just settle now. Now after this all these four would belong to this. All these four would belong to this. The new cluster center would be C1 and C2, and I know after this it will converge because there would be no change of cluster center, there would be no change of members now. So I hope you can see how does this thing changed this time. So I would just like to draw the boundaries only. So over here, if I just talk about, this was alone over here and all this was belonging to one cluster. After that, I recalculated the center. Now this was the case, but if I now calculate the membership, now this one was the cluster and this one was the cluster. So based on that, I got this one as the cluster and this. Now what happens is, after this you can see, if you calculate the what should I say, cluster center, it would change again and it would become this. So I hope you can see now, for the same problem, for the same problem, the initialization matters. Initialization might return different set of cluster centers, okay, or different cluster itself. So it matters a lot. We should have a good initialization. That's why it's being said that we should run k-means for a number of iteration to see when I'm getting the least possible error. So it would converge, both converged actually. Now what can be the error I'm talking about is, so error would be not exactly error, the loss function, I can just say. That means what I would do is, for all the center, for all the members belonging to a cluster, I would calculate the summation of distances of all. So I would calculate all the distances of all these 4 data points to C1 plus all the distances, summation of all the distances of all these data points to C2. Overall distance should be lesser. Okay, it should be minimized, because if it's a good cluster, I would have something like that. But if you just consider this one, you can see this one is quite farther from C1 as compared to over here. If you just consider this one, this is much better clustering than this one. Over here, you'll see the end extreme data points would give more distance contribution to your loss, or what should I be saying? Like, it would be giving you more kind of a judgment that it's not really a good clustering which you have done right now, because the cluster members are a little farther than what you can think of. But over here, it's much better. So overall, you will just evaluate the different clusters. You run it for multiple times. You initialize randomly sometimes, or sometimes can be a better way of initialization, which is like k-means plus. If you have heard about that, no, it's okay, which does a better smart initialization, and based on that we actually find out the clusters. Okay, so k-means is not just run for one iteration as in, like, the moment we get cluster, we do not really stop. We actually try finding out multiple times, so that then I can evaluate which one is the better cluster, because it is prone to these kind of problem based on initialization. If I have a bad initialization, I might not get a good clustering. Okay, so this was overall k-means algorithm, where we actually this is an unsupervised learning. We are just finding out that which data point belongs to which cluster. At testing time, if I were to find out that, okay, to which cluster it would belong, I just need to give one data point and it would just tell me to which cluster it would belong. Okay, and then it would update the cluster center as well. So it's something like this only. So that was the idea. I hope it's clear. In case of any issue, you can always just reach out to me. I hope it was clear. You enjoyed it. You got the basics. You'll be able to solve the problem now. With respect to k-means, what other things can be talked about is, so yeah, initialization is an issue, but better initialization. What are the problems with k-means? It's something on the similar line as to what KNN also does. So it's a distance metric we use over here. So distance metric also matters. What is the choice of distance metric we are using? Okay, and yeah, sometimes if it's high dimensional data I'm having, then it can suffer for curse of dimensionality. Both of these can suffer, because I would be using the distance metric, and it would be a little difficult to find out. So yeah, that's all about both the algorithms. So I hope you could understand the K in both actually a different thing. They signify different thing, and similarly, one is supervised, one is unsupervised, but they have a same underlying principle. What was that? That the similar looking data points would be lying in close proximity of each other. That's the classic basic idea around this, fundamental concept around this. So I hope you love the lecture. Now I'll end this lecture, and we'll see in the next class. We'll discuss the next class what is the next important topic which we can discuss. So till then, bye bye, take care, and thank you. And you can solve the problem from RIC batch, or if you need some more problems, you can just refer to some standard resources. That would be easier. Or PYQ also, you'll be able to solve. Like if it's based on simple clustering, you'll be able to find out the answers easily. That was all, guys. Thank you. Thanks a lot.